If you remember with me a little bit, the theory of trigonometry, that's that unit circle. Okay, the unit circle and all the stuff that's true about sine and cosine is what we typically say is the theory. Now, after the theory of trigonometry, we looked at the triangles of trigonometry, right? Remember, you got chased by an alligator. We tried to solve for the missing dimensions of a triangle. That was kind of fun times, the triangles of trigonometry. Okay, and then really what we just got done doing, of course, is the graphing of trigonometry. Now, there's one more thing that we do when it comes to trigonometry, and that is the algebra of trigonometry. You're going to feel like we're focusing more on algebra ideas. And when we talk about the algebra of trigonometry, we are actually talking about, let me get this here for you. When we talk about the algebra of trigonometry, okay, we're going to be doing everything that you could do in an algebra class, meaning like solving equations and meaning like simplifying expressions and many other things. We'll be doing all that stuff with sine and cosine. We'll be doing it all with sine and cosine. And you'll find out that that will fit into a category that we typically call trig identities. Trig identities. Okay, now trig identities, it's going to be new. Okay, it's going to be new. I'll sort of be honest with you too, it's probably one of the harder things we do all year. But I'm only saying that just to be honest. That doesn't mean you can't do it. You might think I say that all the time, but kids will typically say that this is one of the harder units, but we're going to take it in a way that can help you learn it. I just don't want you to be surprised if some things come up, maybe even today, that you're kind of like, that's kind of different. You know, it's new, and maybe it's going to take a little while to understand it. That's all why we're here. Now, trig identities. What's an identity? Okay, well, if you think about the word identity, kind of like just in a simple English context, you know, if I ask you for your identity, you're going to explain who you are. Okay, you're basically going to explain what you equal, although you might not think of it that way. That's what a trig identity is. It's basically something that is equal. Actually, I have it written up here that an identity is just a statement of equality. An identity is simply something that's equal, a statement of equality. Let's not make this too hard, okay? Because I want you to understand that you already been around statements of equality. Back in first grade, really, when you guys learned that 1 + 1 = 2. Maybe you learned that before that. But in all seriousness, 1 + 1 = 2 is an identity, okay? Because it's equal. What we're going to do are some statements that involve sine and cosine that are equal, and that will be a trig identity. Now, I like to add to this, no matter what, just a little emphasis that when we talk about these identities, they will always be true. Yep. Maybe you're not really sure why I'm saying that now, but even tomorrow I'll show you what I mean by no matter what. Okay, they're always true. They're always equal. You've actually been around some identities. Believe it or not, there's actually some identities that you may feel like that you could, well, do a little pre-test with me. I don't know if you really need to write this down. You can always write down whatever you want, but just think with me here about a couple statements that, well, that might be true or might not be true. Secant equals 1 over sine. Secant equals 1 over sine. Maybe that's looking like a question from the test. It's not exactly from the test, but it is similar. But do you know if, would you be able to say if this is true or false? Okay, again, it's not exactly from the test, but it is similar. All right, now this one's false. Maybe the reason it's false is because there's something else that equals 1 over sine. What does equal 1 over sine? Good. That's exactly right. Cosecant's what equals 1 over sine. Now, be careful if you're like, whoa, am I supposed to already know that? It's something that we've kind of been talking about off and on. We didn't talk about it every day, but if you didn't know that, we're certainly going to be using it in this chapter. And so cosecant. Now, if you're like, why is that true? It's just by definition. It's just by definition. And when I say definition, I mean like from the beginning of the year. So let's look at another one. See if you're able to say if it's true or false. Again, I don't want you to be like, well, did we already talk about this? I don't know. Maybe we talked about something that would allow you to say if this is true or false. Is there anything in your math gut that you're sort of leaning one way or the other? Your math gut. Okay, well, it would be true. And I'm appealing to maybe those of you that were thinking so. Would you care to share why? Do you think you have a reason why? It's all right if you don't. It's not like we talked about it straight up, but sometimes students will think about X, Y, and R. Were you thinking about X, Y, and R? Tangent is Y over X. We've seen that more than once. Sine is Y over R. Cosine is X over R. If you do a little bit of math, those R's are going to cancel out, and you're going to end up with Y over X. Okay, so both sides are equal. Now, you don't need to know anything else except what's up on the screen right now. And, I hope you're still thinking. But all you need to know is what's up on the screen. What I mean is all you need to know is that tangent is equal to sine over cosine. Now, since tangent is equal to sine over cosine, we could do some algebra. Okay, I told you this is going to be the algebra chapter, so this is kind of our first algebra. You say, what do you mean do some algebra? Well, you've done this before. If you have something in the denominator, you can multiply that to the other side. What happens if you multiply cosine to the other side? You get tangent times cosine. You get tangent times cosine, which equals sine. Now, what I'm trying to show you here is that if you do something that's legal, you end up with something legal. You end up with another true statement. Okay? And remember, if it's true, it's an identity. An identity is simply a statement of equality. One more, I think. One more. Sine plus cosine equals 2. Now, we'll sort of cut to the chase on this one. There is no reason that you honestly would know. There really is no reason that you would know that this is false. Okay? But there is something true that uses sine plus cosine. And what we're saying is that sine plus cosine does equal something. It's just not equal to 2. Now, to learn what it equals, we're going to go back to that's supposed to be a little bit of a hint. I even used the right number of hearts. Yeah. I love the unit circle. Okay, now we're going to go back to the unit circle and we're going to discover something that is true. Okay, now to do this, take that little half sheet of paper that you grabbed on your way in and let's kind of dig a little deeper here. Dig a little deeper with me. Now, there's kind of another piece to this little activity. We're actually going to also try to get the Pythagorean theorem to talk. Sounds kind of corny, but we're really going to figure out what the Pythagorean theorem says about the unit circle. All right. Now, to help us do this, I created a diagram At least I kind of started a diagram. Maybe a diagram that you feel like you've kind of seen a little bit before. We've seen diagrams where we have like the unit circle. We also have an angle. It's theta. And notice that it's intersecting at a point. Now, the rest of it's kind of up to us to try to get some fill in, to try to get some information to this diagram. Let me start us out, but the point behind this, see if you guys can kind of add some of the stuff. But let me start us out with something that, well, maybe is a little bit familiar. That is making a triangle. Making a triangle. As I suggested, does that maybe seem a little familiar? Something that, we've done before. It's been a while, but you actually have made triangles like this. What's true about this triangle? Tell us some more. What is true about it? What else could you add to this diagram? How about that hypotenuse? Were you thinking about its length? How long is it? Why is it 1? Why is the hypotenuse equal to 1? Good. The radius of the unit circle. Good. It's the radius of the unit circle. Okay. How about the other dimensions? The other dimensions. Now, if you were thinking that you're supposed to know what they equal, not like that they equal 1 or not that they equal a number, but let me guide you a little bit here. There's certainly nothing wrong with me saying that the bottom dimension is the same as x and the vertical dimension is the same as y. Now we're trying to get the Pythagorean theorem to talk. Just to keep you engaged, it could talk right now. It could say x squared plus y squared equals 1 squared. Okay? That's not quite where we want to go, or maybe I should say that doesn't quite use all the information because we've got that theta down there. That theta seems like it should also be part of this conversation. And it will be once we remember that it helps us think about this point. Now, this is like the whole theory of trigonometry. Like if there was one question on a test, it would be this question. What's the value of that point? And sometimes we forget, and sometimes we're still not sure if we understand, but the value of that point is the cosine of that angle. And what I'm appealing to is way back like in the beginning of trigonometry, that's what we defined cosine to be. It's the value of that point. Well, it's the x value, right? And then the sine is the y value of that point. Now that statement means that any angle, if you do its cosine, you'll get the x value of that point. If you do the sine, you'll get the y value of that point. But that allows us to go back down to our triangle and make one more connection. Instead of just saying that the bottom is x, we now can say that the bottom is the cosine of theta. Instead of saying that the vertical dimension is y, we can say that the vertical dimension is the sine of theta. It's getting ready to talk. It's not the sound of that hammer drill, but it's something else that it sounds. There's another sound. The Pythagorean Theorem. Can we get it to talk? What would it say about this diagram? Let me guide you along here. It would say that cosine squared plus sine squared would equal 1 squared. It would say that cosine squared plus sine squared would equal 1 squared. And when you take that statement, cosine squared plus sine squared equals 1 squared, and you kind of simplify it a little bit and clean it up a little bit, you end up with almost the same thing, but you end up with what I kind of want you to see, and that is that sine squared plus cosine squared equals 1. And you can see that I wrote it a little differently, but take a look, it's basically the same thing. And again, it says that sine squared plus cosine squared equals 1. Now, this is a big moment, at least mathematically, it's big. I want you to realize why it's big, okay? And that is simply that statement. I know it's kind of new, and maybe you're like, what does that really mean? But that statement is an identity. It's true all the time. It's true that sine squared plus cosine squared equals 1. Okay, and I can tell you guys, some of you can't get your eyes off of it. It is quite a thing of beauty, isn't it? It's quite a thing of beauty. Now, in my life, I've encountered a lot of things of beauty. One of them is my wife. I met her in high school, so she is definitely number one on the list. But I'm telling you, a close runner-up is sine squared plus cosine squared equals 1. Okay, it is a mathematical thing of beauty. It's on video, so I'm going to get thrown under the bus here, but it too hopefully will be top on your list, at least top on your mathematical list of things that are beautiful. Now, in all seriousness, if you do see me out and about, maybe you see me at Lowe's shopping for some tools or something, you should be able to say, hey, Miss Naylor, sine squared plus cosine squared equals 1. Let's practice it. Sine squared plus cosine squared equals 1. I actually had a student say that once. I think I was at the grocery store, which I was lost. I always go the wrong way. Guaranteed, if I need to get milk and it's to the right, I go to the left. I always seem to choose the wrong direction. But a student did once. They were like, Miss Naylor, sine squared plus cosine squared equals 1. And I was like, huh? I was not in teacher mode, but I was very proud of that. It's a true story. I'm not making it up, but I want you to remember this. Now, if you're like, how come you wrote the squares like that? It's notation, and we'll talk about it, but it just means that you're squaring, like I showed you originally, that you're squaring the leg, and then you're squaring the other leg, and it equals the hypotenuse. Okay? Now, what I want to do today, this is kind of like an intro day, but by no ways is it we're just kind of wasting time. But what I want to do today is I want to show you guys that there are actually 3 categories of identities. Now, this is the big one. It's called the Pythagorean. But you're probably going to want to shift to kind of a full page of notes. Keep that half sheet handy. I hope it's something you can staple or tape or put in a folder. But kind of switch back to a full sheet of notes. And get ready. Okay, get ready, because we're going to take what we learned here and show you guys in a moment that there's actually more identities. There's more Pythagorean identities. All right, but sine squared plus cosine squared equaling 1, it's at the top, okay? It's really the main idea of this whole chapter. By the way, we can use theta, we can use x. I'm kind of switching it up a little bit. I'm using x. It's a little easier to write, but ultimately there has to be a variable there. All right. That lovely statement is true. But since it's true, we could do something to it. We could do algebra. Okay, now there's no reason I would expect you guys to say this, but just agree with me that if I wanted to, I could divide by whatever I want. As long as I divide everything, this would still be true. But to lead this conversation, I'm going to suggest that we divide by cosine squared. Now, as I said, I wouldn't expect you guys to say, hey, divide by cosine squared. But I do hope that you're saying, okay, you're allowed to do that, Miss Naylor, as long as you do the same thing to all parts of the equation. But the reason I'm doing that is because we start to get some interesting results. Sine squared over cosine squared. Now, that kind of looks a little bit like sine over cosine. And a few moments ago up here on the screen, we said sine over cosine was the same as tangent. But since it's sine squared over cosine squared, I want to help you begin to understand that that would be the same as tangent squared. Sine squared over cosine squared is the same as tangent squared. Now, don't worry if you're like, I don't know. Don't worry. We're going to keep talking about it, but it's true. It's definitely true. What about this? Cosine squared over cosine squared. What happens if you have a numerator and a denominator that are 100% equal? They're going to cancel out to be 1. They're going to cancel out to be 1. So cosine squared divided by cosine squared is 1. 1 over cosine squared. We didn't have this one up on the preview, but there was one that was similar. And so just like 1 over cosine is secant, this would be secant squared. Take a look. That's a new identity. It's interesting. Tangent squared plus 1 is the same as secant squared. Tangent squared plus 1 is the same as secant squared. You'll start to catch on, but this is new, and I understand that. I'm going to suggest that we divide by something else. I know I just kind of erased it. You have to decide in your notes how you want to maybe remember this. Maybe you just want to keep watching because it's legal. I can divide by sine squared. Now, if you're saying, why are you doing that, Ms. Naylor? Why are you doing that? Well, take a look. We get some new results. Sine squared over sine squared. That's the same as 1. Now, cosine squared over sine squared. We haven't talked about that. Okay, we haven't talked about that. But cosine over sine, now that would be the same as cotangent. Since it's squared, it is true that it would be cotangent squared. Here's this 1 over sine squared. We did see it a moment ago in the little preview. As was said, it's equal to cosecant. Except for this one, it would be cosecant squared. Now, these 3 statements, these are the Pythagorean identities. These 3 statements are the Pythagorean identities. Okay, interesting. At least agree that they're interesting. They are true. And of course, they all came from this beautiful statement about the unit circle. We're not done yet. We can actually do some more algebra. Okay, like some rearranging algebra. You'll start to see, but let me show you that I could legally subtract cosine squared, right? I mean, legally I can subtract that. Now, if I subtract cosine squared, I kind of get like a different variation of this identity. I get the variation that says that sine squared equals 1 minus cosine squared. Sine squared equals 1 minus cosine squared. Now, that's the same identity. It's just kind of rearranged. Same thing here. I could subtract sine squared. I could rearrange it. And I really just end up with a different variation. I end up with the variation that says that cosine squared equals 1 minus sine squared. Now, if you're already starting to wonder, what are we going to do with this? Well, that's what the chapter is all about. Okay, today we're just kind of creating some of these statements, but I promise we're going to do stuff with these. And it's going to feel like we're doing some algebra, like we've already done a little bit today. I'm going to choose to only rearrange this one once. Although we could subtract whatever we want, I'm going to subtract tangent squared because you kind of get a sort of a snazzy statement here. You get a snazzy statement. It says that secant squared minus tangent squared, now that's equal to 1. Again, it's just kind of interesting that if you subtract tangent squared, you get secant squared minus tangent squared equal to 1. And we could subtract other things. We could move stuff around. You'll get the hang of it that you can do that. Let's, for this identity, kind of do the same thing. We're just going to subtract cotangent squared. Again, you kind of get a neat variation. It's the variation. It says that cosecant squared minus cotangent squared equals 1. All right, all those statements over on the right, they are also true. They're really, though, just variations. And as I hope you see, they're just kind of like subtraction variations. All right, now there's some more identities. We'll go a little more quickly through these. There's 2 more categories. The one category is the reciprocal category, reciprocals. And I want you to understand as I start to write them down that they do not come from the Pythagoreans. The Pythagoreans, they are very unique. Okay, they came from the unit circle. The reciprocal identities, they more just come from like the definition. Like to say that cosecant is 1 over sine is really just the definition of cosecant. Cosecant is 1 over sine. Again, you might kind of feel like that you've seen that before. In fact, you saw it up on the preview, and we even talked about it off and on throughout the last few months. In the same way, we can say that sine is 1 over cosecant. Please understand that both these statements are saying that they are reciprocals. Maybe you feel like you could fill some of these in. I'm just pausing if you want to kind of think, because secant, now that was on the test. Okay, even if you got it wrong on the test, we can still get it right today. Secant is 1 over cosine. Again, just by definition. And in the same way, cosine is 1 over secant. And then, of course, there's the cotangent, which wraps up this group here. Okay, that's going to be the reciprocal of tangent. So that's 1 over tangent. And then tangent is 1 over cotangent. Maybe it's crossing your mind that, maybe the question's crossing your mind and wondering, do I have to memorize these? Okay, I'm just going to try to put you at peace right now. You do not need to memorize these. Even on the test, you'll have a place that you can look at these sort of these identities. However, if you're going through this chapter with me and you're trying to learn, many of these you will memorize. Okay, many of them you'll memorize because you'll find out that we kind of continue to use them, and many of them are related. But to, again, give you some peace, you're not going to be forced to memorize when it comes time for a test. Quotient identities. Quotient. Now, quotient is a fancy word for division. Division is often shown as a fraction. So that's why tangent shows up, and we say that tangent is sine over cosine. Tangent is sine divided by cosine. Okay, maybe a statement that you're kind of feeling already a little comfortable that that is true. 100% that's true. Now, if I multiply cosine to the other side, if I multiply, which would be some basic algebra, I would get another statement that is just a variation of this. And that is that sine is equal to tangent times cosine. Sine is equal to tangent times cosine. Even though that's not a division problem, it's actually a multiplication problem, it's still a quotient identity because it came from this. One more. After we do this last identity, I have a little preview activity that I'm going to ask you to begin looking at. It's actually on the computer. But cotangent is cosine over sine. It's just kind of like the flip-flop. If I multiply sine over here, I can create myself another variation. And that variation would say that cosine is equal to cotangent times sine. Cosine is equal to cotangent times sine. That's actually all the identities, okay? The main part of this chapter is going to be, what do we do with these? And again, you got to come back every day. We'll show you what we do. But to kind of give you a little bit of a preview of that, and to start to get you guys just thinking about algebra, there's something on Google Classroom that I would like you to look at, even though you're not going to finish it. I want to see you kind of boot that up, and you'll probably go through a couple slides of it. Okay, now it's something that you're going to want to finish as homework, but why don't you go ahead and take a little look at it now. Let me carefully say that although I don't expect that you're going to know all the answers, I still want you to try. I want you to give it your best preview, okay? Because there are some things that you should know, and actually give you some ways that you can start to transition from basic algebra to the algebra of trigonometry.